We are discussing regarding the synthesis of carboxylic acid. So I have R, C, O, O, H. This functionality is carboxylic acid. The moment we say it's acid, we understand they are acidic in nature. That means they can release H plus ion. The reason why they can release H plus ion is that this carboxylate ion that you have formed has an ability to get involved in the resonance. The resonance stability of carboxylate ion makes it acidic in nature. So there are different types of carboxylic acids are there. For example, I have monocarboxylic acid. The very first form of carboxylic acid is formic acid or methanoic acid. Only one carbon is there, so we call it formic acid or methanoic acid. The next one is ethanoic acid or acetic acid. Among the IUPAC nomenclature, carboxylic acids after sulfonic acid, carboxylic acid is given the priority for this. So consider I am having a carboxylic acid like this. So I start giving the number from that carboxylic acid only at first. 1, 2, and 3. 2-methyl propanoic acid. Consider I am going to have more than 2 carboxylic acid in the same parent. Whenever you are having the same functionality more than once, then what do? You take the parent chain 1, 2, and 3. At the first and second position, I am having oic acid. So what is the parent here? 3 carbons. So it is propane 1, 2 dioic acid. We are discussing about the nomenclatures of the carboxylic acid. You have to give importance to the carboxylic acid. Give the number 1 priority from that carbon containing carboxylic acid. If more than once the same carboxylic acid is available, then choose a parent chain. Give the lowest number to that carbon which is bearing the carboxylic acid and take the parent chain and give the number of them which is containing this carboxylic acid and mention how many oic acids are available for us. The next one is about geminal and vicinal acids. Geminal and vicinal acids. Here, 2 carboxylic acids are attached with the same carbon itself. So we call this as gem acids. Here you can see the 2 carboxylic acids are attached to the adjacent carbon. So we call this as vicinal acids. Going for the synthesis of the carboxylic acids. The first synthesis is the oxidation of primary alcohol by any strong oxidizing agent, dichromate or permanganate. Usually when an primary alcohol is provided and you are provided this kind of a strong oxidizing agent, they complete the procedure by forming acids. But if your question is asking you for an intermediate that is formed here, which is further undergoing oxidation, and in that case, you mention it as aldehyde that is getting formed, and the second product would be acid here. The first common method of synthesizing the carboxylic acid. The next method is by taking the oxidation in the presence of concentrated nitric acid of ketones. So we have learned about a rule called as Popov rule, where when you are having an unsymmetrical ketone, retain the carbonyl group with the less number of R. So here I am breaking it this way. so that this C double bond O group is becoming carboxylic acid. Similarly, that carbon which is attached to this carbonyl, this group, is also getting oxidized to carboxylic acid. For example, I am taking acetone and I am oxidizing it. Here, both are symmetrical. For me, this side becomes acid. Also, this part becomes acid. So, the second synthesis procedure of the carboxylic acid, where you take the ketone, you oxidize them to get carboxylic acid. The next procedure is from nitriles. Nitriles upon hydrolysis. So, I have RC triple bond N. When I first hydrolysis it, the first product that you have here is amide. The first product that you will have here is amide. Upon further hydrolysis, you will get carboxylic acid plus ammonia as a gas. In case they have not provided you the intermediate amide here, ma'am. They didn't provide me this. Instead, they said complete hydrolysis, or they mentioned water in the presence of H plus. Acidic hydrolysis. In that case also, your direct product will be carboxylic acid. I am having acid halide here. Let me say it is RCOCl in the presence of water. In the presence of water, here also you can see water is having a neutral nucleophile which is going for an attack, which will release it, so that you will have RCOOH plus HCl, because this will become O plus H2. Release of H plus will give you RCOOH, and then you will get HCl. That's what I have written in one single step itself here. So any acid derivative for that matter, I am mentioning any acid derivative, you'll get the same product only. We are taking succinic anhydride. So we are discussing the synthesis procedures here. We started with alcohol, we oxidized it. We took ketone, you oxidized it. You took nitrile, you hydrolyzed it. You took acid halides, you hydrolyze it, or any acid derivative, you hydrolyze it. Now we are going for anhydrides. Now, how do you actually synthesize an anhydride? From dehydration of the 2-carboxylic acid. Let me say I'm having succinic acid. I'm going to dehydrate them. Okay. What will you form? What you form here is anhydride. Look at the reaction here. I'm having 2 carboxylic acids here. This is vicinine. I'm taking vicinal dioic acids here. I heat it. Water is removed. You form anhydride. Then what about the reverse? When I take the anhydride and I'm giving water to it, it will again produce the same carboxylic acid units in the parent chain. That's what the reaction is providing you. I take succinic anhydride. To this, I am providing water. So this would hit this, and this could move out, so that I am having COO plus H2 and COO minus. One of the H plus could get transferred over here, which would form C double bond O OH and C double bond O OH. So when I take dioic acid, you heat it, what you form is anhydride. Take the anhydride, add water. What you form is dioic acid. Just the reverse of them.
Yes, ma'am, got it.
Yes. They're asking you, it's going to produce 2 moles of benzoic acid upon treating something with water. I understand very well, and anhydride only should have formed it, isn't it? It need not be a cyclic anhydride. It could be a common anhydride also. Consider I'm having benzoic acid. I'm treating with another mole of benzoic acid. Heat it up, release the water. What you're forming is benzoic anhydride. Now, when you again give water to it, it would produce same 2 moles of benzoic acid itself. I understand. What I have taken here is benzoic anhydride.
But it could have also been like the nitrile group attached to benzene, right, ma'am?
I told 2 moles specifically.
Oh, yes, ma'am. Okay.
Okay, 1 minute, I'll be back.